Today, we're going to solve systems of linear equations in context. So basically that means when given a story problem, we're going to make a system of equations and then we're going to solve it. So we already know how to solve it. So really today, we're going to focus on how to make that system of equations. So when we do it, we need to keep things organized. One way we can keep things organized is to define the variables. Defining variables means we will write down the variables or the letters we will use. Usually we use X and Y, but you could technically use any letter you want. And you need to state what they represent. We will then write two equations for each problem, since we're solving systems of equations. Remember, most story problems end with a question that will tell you what you're looking for. So always focus and key in on that question. We're going to skip the first couple of examples and do example 3. A farmer has 38 animals. Some of them are chickens and the others are cows. Altogether, these animals have 124 legs. How many chickens and how many cows does the farmer have? Now, this question seems really weird because it's hard to do, usually you can picture what things are happening in your head, but this feels like it's all very disjointed. Remember that we're solving this with a system of equations. Anything that is looking for two variables, so two unknowns, and we're looking for chickens and cows, and has two relationships between those unknowns, and I have a couple numbers, so I think those might be it. It can be solved by a system of equations. So let's start by defining our variables. I'm going to use the question, and I'm going to just say X is the number of chickens that the farmer has, and Y is the number of cows. Now I need to make some equations that relate these. So apparently he only has chickens and cows, and he has 38 total. So that tells me that the number of chickens plus the number of cows, this is the number we're working on, equals 38. Then there's this other number over here, which doesn't have to deal with the number of animals. It has to deal with the total number of legs. So anytime you're talking about altogether or a total, that usually indicates that that number is going to be alone because it's the total. And a lot of students make this mistake. They're just like, okay, altogether 124, altogether 124. But it doesn't make sense for X plus Y to equal both 38 and 124. So there's something else that's got to happen here. There are numbers that they don't tell you because they just assume that you know. If we want the total number of legs, then we'll have one part of legs that is chicken legs and the other part of legs that is cow legs. And the number of chicken legs is not the same as the number of chickens because each chicken has 2 legs. So we're going to say twice the number of chickens and 4 times the number of cows will be the total number of legs. And you can always demo this. Like if we want to say that if we have 1 chicken and 2 cows, then how many legs do they have? Well, that has 2 and that has 4. Okay, I can see that there would be 10 legs total. So you can always demo it out to make sure that you did the math right. So those are my 2 equations, and that's really it. You can think it through and demo some numbers like I just did. Once you have these equations, then you need to solve it. We've learned how to solve by graphing by hand and by graphing with a graphing calculator. I'm just going to put these in my Desmos graphing calculator and see what I get. So let's go to Desmos. So I have X plus Y equals 38 is my first equation. And my second equation was 2X plus 2Y equals 124. So my equations aren't showing up on my Desmos, so I'm on an iPad, so I'm just going to zoom out and see where they show up. Ooh, wow, they're way up there. So it looks like, why do these look parallel? Ooh, I think I did something wrong. I have 2x plus 2y equals 124, And remember that a cow has 4 legs, unless you are having a really weird farm. Okay, so the point of intersection where both equations are true is 1424. So this is the only place where you can have 38 animals and have 124 legs where there's chickens and cows. So we're going to take this 1424 and put it back in our problem. However, we're not done yet because this asked a question. So after you've solved it, you need to actually answer the question. 14 was X, so that's our number of chickens. He has 14 chickens. And 24 cows. Now, I would like you to not only define your variables and show the equations and then solve them, but since we're not really doing a whole lot of work on these, I'm going to show checking my equations. So, does 14 plus 24, this is the first equation, so right there, does that equal 38? Well, I can do this one in my head, and yes, it does. Then this one's a little harder. Does 2 times 14 plus 4 times 24, does that equal 124? I'm going to do this in my phone calculator. You can do it in your calculator, and we'll see if we get the right answer. 2 times 14, so 28. 4 times 24 plus 28. Okay, yeah, I got 124. So both of these equations are true, so I got the correct answer. If you are not getting the correct answer, then something happened. Maybe you entered in your equations wrong. You might also want to make sure that you check your equations and make sure that they make sense with an example, because it could be that you solved the equation completely right, but maybe you wrote the wrong equation. Let's go ahead and do example 4. This one's going to be different. Mr. Ricks has $500 in his savings account and Mr. Campbell has $900 in his. Mr. Ricks is adding $50 per month. Ooh, I see a per month. That gives me a clue that this might be a rate of change. Whereas Mr. Campbell is contributing $30 per month. Write an equation that represents the amount in each savings account and determine when they have the same amount. That was kind of a lot. Okay, so this final question is usually where we find our variables. Let's actually go over here. So the amount in each savings account has to be one variable. So, and it actually matters on this one. And determine when they have the same amount. So when, that's like a time. And since we have it's talking about months, we're going to say after a certain number of months will be our variable. And then the amount in each savings account is measured in dollars. So this feels like a rate of change, and these are initial values. So if this is my y-intercept, then that tells me that the dollars must be y. So I'm going to put dollars in savings account because that was the first thing in my question there. Then the other variable, number of months, will be my x. Okay, I'm going to erase my scratch work here so that I can write some equations. All right, so now I need to write 2 equations. And remember, you're thinking of 2 different relationships between months and money, and this one's a little easier to picture. I can see that Mr. Ricks is going to have an equation and Mr. Campbell is going to have an equation. So we're going to make Mr. Ricks red, and then Mr. Campbell will make him blue. So $500 in his savings account. Okay, so this is going to be a y equals mx plus b equation. And it says Mr. Ricks is adding $50 per month. So that tells me that's going to be my rate of change because of the per. So if there's a per, that means it's multiplying times whatever the per thing is. And our per thing is X, so we're going to put 50. And then he has $500 to begin with, so that's my initial value. Now we'll write Mr. Campbell's equation. Y equals his starting point is $900, and then he has 30 per month. All right, so now we have two equations. Now we just need to solve and find when they have the same amount of money. I'm going to go ahead and graph these. All right, y equals 50x plus 500. And then what was my other one? 30x plus 900. Y equals 30x plus 900. Okay, so this looks a little weird, so I'm going to zoom out a little bit. Oh, man. These just look really steep, and it's really making me feel a little wonky. So I'm going to make my y-axis go from 0 to 500, maybe. And then x-axis doesn't make sense to start before 0. And then, yeah, sure. Oh, it goes on a long ways. Wow. Okay, so then they intersect right there. And that point of intersection is 20, 1500. I'm going to write this over here so I have some space to answer my question. 20, 1500. All right, so now we answer the question. Well, this says write an equation that represents the amount. That doesn't make any sense. Let's just say that it asked, find when they have the same amount. Okay. So we're going to say they have the same amount after, so X was the number of months, so after 20 months, and that amount is, and they both have $1,500. You could also write, they both have $1,500 after 20 months. I didn't write that the best way. Okay, I'm going to check and make sure that this works in both equations. Let's put in 20, 1,500 in for each. So 1,500 will be our y. Does that equal 50 times 20 plus 500? And I can, 20 times 50 is 1,000. So 1,000 plus 500, yeah, that's 1,500. Okay, so then 1,500, does that equal 30 times 20 plus 900? So 30 times 20 is 600 plus 900. Yeah, that equals 1,500. You could also plug it in your calculator. So I was right. We did great. So I would like you to show defining your variables, then making your equation, answer the question, don't just write a point, and then show your work at the end. So there's really four steps here, but that way you make sure that you never messed anything up. Good luck.